students, there's a couple different things that I wanted to talk about in this video, and this is going to be going back to the way basics. And that is generally just going to be the different types of chemicals that are going to be on different sides of a membrane. So if we have our cell and we have our external surface and our internal surface, or oftentimes it's going to be called the luminal side, so within the lumen of something. So if we're talking about your gut or other things, or the extracellular side and intracellular. Actually, let's call it that instead of luminal, because luminal, once again, tends to be outside of the gut. And then if you remember this is going to be a phospholipid bilayer. So it's a phospholipid, which has a phosphorus section and bilipid tails. So they kind of look like the Starship Enterprise. At least that's how I've always pictured them. So if you were to look at a drawing of one, I'll draw it over here. You have your phospho and then your lipid tails, and then another lipid tails with another phosphorus, and then you have your hydrophilic and hydrophobic regions. That essentially makes it so that we have certain things that can stay out and certain things that can stay in. So there's going to be some things that will readily go through this. Generally, anything that is hydrophilic won't pass through it because of this hydrophobic region. So if we have hydrophobic things, so small hydrophobic, can generally go through. They need to have some sort of carrier molecule to make their way to the membrane, but otherwise they can go through. Small molecules that are nothing, so like oxygen, can generally go straight through. Okay, carbon dioxide, other things along those lines. So this would be hydrophobic, let's say just small lipids, lipid hormones, like vitamin D, for example, that can go through. So then there's also going to be other different types of things that can go through channels. So if we have a channel, then you can have, or a pore or a membrane, then you can have other things that can go through, and they'll follow their electrochemical gradient. Now, generally, the way that this is going to be set up is that we have high amounts of sodium on the outside and high amounts of potassium on the inside. There's going to be a couple other different types of molecules that are going to be common in extracellular portions. So chloride is going to be one of them, calcium is another. So we have all of these that will generally be in higher concentrations on the outside than the inside. Potassium is going to be the major player when it comes to intracellular types of ions. When we have this different type of gradient, then we can use that to our advantage to be able to do a variety of different types of things, and I'll talk about that in a different video when we're talking about different types of transportation. Generally, though, this is all going to be established through the use of a variety of different types of pumps and channels that will push things in one way or another, or out a different way, to create this electrochemical gradient across the lipid bilayer. There are going to be some things that are also going to be too big to go through unless they have helper proteins that can help push them through one side or another. But really, when we're talking about it, the lipid bilayer is going to keep some things in, some things out, and then also be a place for, say, communication proteins, where we have something that is going to be embedded in the membrane or embedded in a membrane, and then it will have a receptor or something else that can make it so that things can happen. We'll talk more about those later. But cell membrane, good times.